Researchers want to test the effect of aging on NBA players' field goal percentages. 9 NBA players' field goal percentages were recorded at the ages of 25 and then once again at the ages of 34, 35. Since Michael Jordan didn't play at the age of 35 and we're doing a test on NBA players, so you got to include him, so we just tested him at age 34. The data is shown in the chart above. Use alpha equals 0.05 to test the claim that aging affects NBA players' field goal percentages. So what test are we using? Well, we're testing between the difference between two means using dependent sampling, which means we are using a t-test. Okay, state the hypotheses. So the null hypothesis, we're just going to assume that mu sub 1 equals mu sub 2, that there was no difference that aging made, and then the alternative hypothesis is that there is a difference in the means. And all this data is found on that website at the link at the bottom. And we're going to solve this problem using the traditional and p-value methods. Okay, so here's the problem we're dealing with, and since it's we're testing the difference between two means, we basically want to put it in one list in stats list editor, and we do that by subtracting the first group from the second group to just get it down to one group. So I'm going to give you those values that come out to be negative 0.284, negative 0.009, 0.079, 0.073, negative 0.01, 0.101, 0.013, negative 0.035, negative 0.02. Okay, so put those numbers in list 1 of stat list editor, and we'll do that now. So basically we're going to use those numbers and plug it into this equation, d bar minus mu sub d over s sub d over square root of n. And x bar is d bar, which is 0.0102, minus mu sub d, which is 0, because we're assuming that the means are the same. And then s sub d is the same as s sub x, which is 0.1137 over square root of n, which we know is 9. And that comes out to be negative 0.2691, and that's our test value. So now to find the p-value, we're just going to find the area to the left of the test value, which can be found using TCDF. We're starting at negative infinity and going to the test value, which is negative 0.2691. And degrees of freedom are n minus 1, which 9 minus 1 is 8, and that comes out to be 0.3973 times 2, since it's two-tailed, gives you 0.7946. That's the p-value. And now before we draw the curve, we got to find the critical value, which can be found using inverse t. So it's t-test. And the area is 0.025 since alpha is 0.5, but it's two-tailed, and the degrees of freedom are 8, and that comes out to be negative 2.306. Okay, now we're going to draw our graph. Two-tailed, as we discussed, makes it 0.025 on both tails, since alpha is 0.05. And we know that the critical value is negative 2.31. And the test value is negative 0.2691, 269, and then we know the p-value is 0.7946, which is significantly greater than alpha. And given this, these results, we are not going to reject. And we're going to write a statement here. Since we cannot reject, we're going to say we do not have evidence to claim that the shooting percentages of NBA players are affected by aging. Good job, Mike. You still got it.